Okay, here are the Conic Sections notes. This is page 3. We're going to talk about ellipses. And an ellipse is an oval, kind of like a squashed circle. Okay, so you're going to notice the equation kind of looks like a circle with one change. So we've got the standard equation of an ellipse. We've got the x minus h squared plus y minus k squared. But notice this time it equals 1. And both our x term and our y term are divided by something. Okay, now, we are not going to get really hung up on a and b. Know that they're interchangeable. The a goes with, whatever is under the x goes with the x. That's going to be our horizontal stretch. And whatever is under the y goes with the y. That's going to be our vertical stretch. Okay? So let's take a look at example 3 and how we're going to set this up so it looks like that standard form. First off, notice it's not x minus anything or y minus anything. This is going to be centered at the origin at 0, 0. But this is equal to 36, and our equation says it's supposed to be equal to 1. And so the only way to make that equal 36 is to divide everything by 36. I have my 1 constant. 4 divides into 36 evenly. I've got y squared over 9. And 9 divides into 36. I've got x squared over 4. And so notice something. In our equation, this is listed as a squared and b squared. So I'm going to write it that way. X squared over 2 squared and y squared over 3 squared. It's x minus 0, y minus 0, so our vertex, no, not our vertex, our center. I'm going to change up a little bit here. Is at the point 0, 0. Okay, now, notice this asks for a couple of things. We want the center. I'm going to skip the foci for a minute. We want to talk about the vertices and the major and minor axes. Okay. So we are going to take a look at what we have under the x, this 2 squared. That tells us, the a tells us how far we go to the left and to the right of our center. So it's x squared over 2 squared. I'm going 2 to the right, 2 to the left. These are our vertices. Okay. Underneath our white, I'm going to mark off that too. Underneath our y, we've got the 3 squared. So b is 3. That tells us we go up 3 and we go down 3. So our vertices are at negative 2, 0, and 2, 0, 0, negative 3, and 0, 3. And here's our ellipse. We're not going to repeat this circle. Jeez. An oval. Our minor axis is going to be our short axis. Which has length, in this case, it's 2a. Whatever's under the x. because we're going horizontally. Minor means it's the short axis. We also have the major axis is the long axis. In this case, it's 6 units long. Sometimes you're given the minor and the major. You got to figure out where the vertices are, where those endpoints are. Last thing we have is the foci. So by definition, every point on an ellipse is the sum of the distance from that point to each of the two foci. Okay. So foci are found this way. Oops. Foci occur on the major axis, and they are c squared equals the difference of our two denominators, but we got to subtract larger minus smaller. So here it says a squared minus b squared. Notice in our case, it was b squared minus a squared. That was our 3 squared minus 2 squared, 9 minus 4. C squared is 5, which means C is the square root of 5. So somewhere between 2 and 3. So our foci are always on the major axis. Here's one focus, 0 square root of 5. Here's our other focus, 0 negative square root of 5. If I were to pick a point on my ellipse, the distance between that point and each of the foci added together is going to be the same no matter what 2 points we pick. Okay. So sometimes you'll be given a focus and a vertex, and you got to figure out where the other vertices are. We're using this formula, c squared equals a squared minus b squared, or b squared minus a squared. Basically, it's the large denominator minus the small denominator. So let's go ahead and take a look at this second example. Notice, just like with the circle example we did before, this is with everything multiplied together and spread out. So I am going to start, again, by grouping my x's, grouping my y's, and moving that constant to the other side. Notice that before I complete the square with the x, I do need to factor a 4 out of both of those terms. I cut the 6 in half right here. That's not what we wanted. I'm cutting the 6 in half. I get 3. I square that, I get 9. Now notice that 9 is trapped inside these parentheses, so it's really 4 times 9. I am adding 36 to the other side. Over on the y, I cut my negative 2 in half. I get negative 1. Square that, I get plus 1. And so I have 4x plus 3 times x plus 3, x plus 3 squared. We created it that way. Y minus 1 squared equals 16. Okay. We want this equal to 1, so we're dividing everything by 16. I get x plus 3 squared over 4, y minus 1 squared over 16 equals 1. And this is going to work exactly the way it does when it was centered at the origin. But now look at where my center is. My center is at x minus h, so negative 3, y minus k, 1. Negative 3, 1. There's my center. And see if we can color code. Again, the 2 is under the x. That means 2 to the left, 2 to the right. The 4 is under that y. That means 1, 2, 3, 4 up. 1, 2, 3, 4 down. Here's my ellipse. Again, kind of that upright egg. So our major axis the length of the major axis is 8. We have a minor axis, again going in that x direction, minor just meaning it's the shorter axis. Which is 4. And my vertices. You will never have to calculate these without being able to look at a graph. But 2 to the left puts it at negative 5, 1. 2 to the right puts it at negative 1, 1. 2 to the left, to the right of the center. 4 down from the center puts it at negative 3, negative 3. And 4 up puts it at negative 3, 5.